Alright, so in this video, I'm going to solve the equation x to the power of 2 minus x to the power of 3 is equal to 80. So, to solve this equation, I'm going to first start by subtracting 80 on both sides. So now I get x to the power of 2 minus x to the power of 3 minus 80 is equal to 0. Now from here, I'm going to replace 80, negative 80, I should say, with negative 16 minus 64. Now, I'm going to rewrite this as, I'm going to first rewrite negative 16 as negative 4 squared, and negative 64 as negative 4 to the power of 3. And I'm going to group x squared with negative 4 squared, and x to the power of 3 with negative 4 to the power of 3. So now, there's two properties that I'm going to use. And before that, I'm going to write this as x squared minus 4 squared, and I'm going to group this minus x to the power of 3 plus 4 to the power of 3. We put this plus because this negative sign distributes. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. And if I have something in the form a to the power of 3 plus b to the power of 3, which is this is equal to a plus b times a squared minus ab plus b squared. So for x squared minus 4 squared, it's going to turn into x plus 4 times x minus 4. I have this minus a to the power of 3 plus b to the power of 3, or in this case, x to the power of 3 plus 4 to the power of 3 is going to turn into x plus 4 times x squared minus 4x plus 16. Now, because both of these terms have x plus 4 in them, I can factor out x plus 4. So I get x plus 4 times x minus 4 minus x squared minus 4x plus 16 is equal to 0. Now from here, this is equal to x plus 4 times x minus 4 minus x squared plus 4x minus 16. I just distribute the negative sign is equal to 0. And let's simplify this even more. I get x plus 4 times negative x squared plus 5x minus 20 is equal to 0. So I get two equations from this. I get x plus 4 equals 0, and negative x squared plus 5x minus 20 is equal to 0. So first, for x plus 4 equals 0, all we have to do is subtract 4 on both sides, and we get x is equal to negative 4. Now, for negative x squared plus 5x minus 20 equals 0, well, first off, we have a negative sign in front of x squared, so I'm actually going to get rid of that by multiplying both sides by negative 1. So I get x squared minus 5x plus 20 is equal to 0. And now, to solve this, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 5, and c is 20. So I get x is equal to negative of negative 5 plus or minus the square root of b squared, which is negative 5 squared, which is 25, minus 4 times a, which is 1, times c, which is 20, all over 2a, so 2 times 1. And this is equal to 5 plus or minus the square root of 25 minus 80 over 2, which is equal to 5 plus or minus the square root of negative 55 over 2. Now, this is equal to the square root of 55 times the square root of negative 1 over 2. And the square root of negative 1 is equal to the imaginary number I. So I get 5 plus or minus the square root of 55i over 2. So this is two more solutions to this equation. Thank you for watching. Please make sure to subscribe, leave a like, and share this to any of your friends and family. Alright, so in this video, I'm going to be solving the equation 5 to the power of x is equal to 50. So to first start with this problem, let's test different values of x. So if x is 1, then I get 5 to the power of 1, which is equal to 5, and this is too low. Now if x equals 2, I get 5 to the power of 2, which is 25, and this again is too low. Now if x equals 3, then I have 5 to the power of 3, which is 125, and this is way too high. So we know that the value of x is going to be somewhere in between 2 and 3, meaning it's going to be a decimal. So how are we going to find the exact value of x? Well, to start, we're going to be using logarithms. So I'm going to take the log on both sides, so I get log 5 to the power of x is equal to log 50. And the reason I'm doing this is because logarithms come with a special property that state that if I have something in the form log a to the power of b, I can actually move the exponent b to the front, so this turns into b times log a. So in this case, I have log 5 to the power of x, and we can think of x as b, and I can move this x to the front, so now I get x times log 5 is equal to log 50. And now remember, we want to find the value of x, so all we have to do that is to get rid of this log 5 by dividing both sides by log 5. So now these two cancel out, and I get x is equal to log 50 over log 5. And now, let's simplify this a little to get the exact decimal value. So log 50 is the same thing as log of 10 times 5. And another property of logarithms is that if I have something in the form log of a times b, this is equal to log a plus log b. So now this turns into log 10 plus log 5 over log 5, which is the same thing as log 10 over log 5 plus log 5 over log 5, which is just 1. And log 10 is also equal to 1. So I get x equals 1 over log 5 plus 1. So now, all that's left to do is do 1 divided by log 5 in my calculator. So I get x is equal to 1.431 plus 1, which is equal to 2.431. So this is my answer.